Alrighty, here we go. Finally, we're getting to the end of this section 7 by tackling today's topic, which is simplifying expressions. So make sure you've got that heading at the top of your notes, and away we go. Learning target today. Woohoo! Do you like the little dancing guys? I think they're kind of fun. I can simplify algebraic expressions. Okay? Simplify algebraic. That's such a good word. Doesn't it make you sound super smart when you use big words like that? Oh, yeah. There we go. Simplify algebraic expressions. All right, here we are. We do have some vocabulary terms today. So here's what I have to have you remember here. Algebraic expression. Look at this monstrosity up there. Holy cow. That is a huge algebraic expression. So that's what one could possibly look like. What does it mean? It means basically you have numbers, you have operations, add, subtract, multiply, divide, powers, square roots, all kinds of good stuff, operations. And the kicker here, because if you just have numbers and operations, you just call it a numeric expression or numerical expression. Because it's algebraic, we also have to have some variables. So that's what it means. So jot that down in your vocab terminology there. And now let's continue on. Here's this giant algebraic expression. I've got x's, I have y squareds, I have another y here and an x and various numbers. 5 here is a constant because it has no variable attached to it, and all the rest of these are called separate terms, okay? Even the 5, which is a constant, is called a term. This is a term, this is a term, this is a term, this term, this term. So actually, this big honker has 1, 2, 3, 4, 5 terms in it. So how would we define what a term is? Well, a term is part of an expression, okay? So this is part of this big giant expression, and they're separated by either an addition or subtraction sign. Not multiplying. See, like multiplying is happening in between the 7 and the x. They're not separated as different terms. They're together as one term. So we just look for add and subtract symbols, and that's what separates each term from each other. Okay? That's what a term is. Last thing I think, well, maybe I didn't have another one. Oh yeah, coefficient. The coefficient then is the number, the constant part of a term. So in our big giant one, the 7 is the coefficient, the x is the variable. In fact, let me put that one back on the screen. 5, well, 5 is just a constant, so I'm not going to really call it a coefficient because it doesn't have a variable with it. In this one, here's the 3. Now this gets a little tricky. What is my coefficient here? Is it 3 or is it -3? Because there's a minus sign there. I am going to train you to stick that sign with the following coefficient, and I want you to think of that as -3. Okay? Okay. What about this one? Oh, there's nothing in front of y. Or is there? There's really a 1 here. So the coefficient is 1. Holy Hannah, look at this thing. What would we call the coefficient of this thing? Well, I look at x over 3 and I say, well, first of all, there's really a 1 in the numerator there with the variable x, but then I'm also dividing by 3. Let me show you something here. Whenever you see this happening where it looks like a fraction, I want you to think of putting the fraction out in front of the variable, okay? X over 3 is the same as 1/3 times x, and now I would call this the coefficient. See how I've kind of pulled that fraction to have all of the number pieces together? There you go. That'll come in handy as we start manipulating things here in just a minute, okay? All right, so that's what coefficient is. You can ignore these guys because I think my example just rocked the house. So now we've got to talk a little bit about, okay, what are terms that are alike and what ones aren't alike? So let me pick a letter like V. I like the letter V because that used to be my first letter of my last name. My maiden name was a V. So here we go. If I have a term like 7V, 7V and let's say 14V, those guys are like terms, okay? Because they both have the letter V or the variable V. Here are terms that aren't alike. 7V and 14x. Bzzzt, not alike. Do you see why? Different variables. What if I had something like 47xy? If I had 47 xy's, notice I have two variables here. That's okay. 47xy and 3xy. Those guys are alike. But if I said something like 47xy and 3yz, nope, 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 not alike. They don't have the same exact letter combination. There you go. What if I had something like negative 4x squared, and if I had something like 5x squared? Those guys are alike, yes. But if I had negative 4x squared and 5x, whoa, actually, those guys aren't alike because it's not enough just to have the same letter. You also would have to have the same power of the letter, the same power of the variable. So here I have an x squared, here I have an x squared. They're alike. Over here, I have an x squared, and then I just have an x or an x to the first power. Bzzzt, not alike. Nope, 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 not alike. Remember my no button?
No, no, no!
Yeah, so these guys are not alike. So you have to train your eyes now to look for things that are alike. When you have things that are alike, then we can talk about simplifying. So if I have terms that are alike, like in this expression here, I have 4x and minus 3x. These two guys I can combine together into one term because they're alike. And all you have to do is add together the coefficients, 4 and think of this as negative 3. Those combine together to give me 1x. Over here, I have a positive 2 and positive 6. They're constants, plain old numbers, and I can combine those to be a positive 8. Now, I have a 1x and a positive 8. 8 doesn't have a variable, so guess what? You are done. So let's try a few of these now. Train your eyeballs to look for like terms. 72p, 12, negative 25p. Aha! Okay, I want you to think of this negative sign as being stuck with 25p, because then I'm thinking really it's like plus negative 25p, and addition has this commutative property, so you can think of this as putting the negative 25p next so that I can combine these like terms, throw plus 12 out there to the end, and now simplify. What we're kind of doing is like condensing or smushing this expression from 3 terms. I can combine into 2 because these 2 will combine. Let's see. Take away 20, that'd be 52. Take away another 5, 47p. And then plus 12 has to come on down, and 12 looks around and sees no other terms that are alike, so just got to sit there. That's as far as you can go. Don't combine these two guys together. Nope, nope, nope. Try another one. Ooh. 3/4 x to the 4th plus x to the 4th. Okay, first of all, are these two terms alike? Look at the variables. Make sure the powers are the same. Now what you have to do, though, is you have to look at what are my coefficients and combine them. This is 3/4. This is really a 1. Add these guys together, 1 and 3/4. Now, I'll be honest. You're going to be tempted to do this, 1 and 3/4, x to the 4th. But I think this is kind of clunky, all right, having the mixed number. In all honesty, I'd rather have you write it as 7/4 x to the 4th. Or if you're a decimal person, you could write it as 1.75 x to the 4th. Okay? But frankly, these two are really better than that clunky old mixed number. So I want you to start retraining yourself to do that, okay? Deal. Next. Ooh, 16p. That's Q. Minus 84p. Keep this negative sign stuck with 84. And then I have a plus Q. Think of that as 1. All right, I want to get my like terms next to each other. I have to keep the negative sign with the 84p, okay? Because it's really like adding this, and I can use the commutative property when I do that. Then I have a 22q and plus another q. Hot diggity dog. Let's combine these terms together, condense this 4-term expression into 2. 16 and then a negative 84. That's going to be negative 70, 68. I hope that's right. I'm really tired, and I'm hoping I'm not making some sort of Speedy Sally mental error there. That's as far as you can go because these two variables are different. We can't combine P's and Q's. There you go. Done. That's as much as you can simplify. One more, maybe. 3m squared. Okay, so it's like you're putting on algebra goggles and you are looking through that expression for any other term that has an m squared. Nothing. So you know what? 3m squared is just going to stay as is. I'm kind of done with him. Okay, let's look at what's next. I have a 12. That's just a number, a constant. Do you see any other constants downstream here? Yes, I do. I want you to think of rewriting the order using commutative property and say, hey, I can combine those guys into one term. 17. All right, so now I've gotten rid of that guy and that guy. Oh, minus this 1m to the 3rd power, but there were no other 1m's to the 3rd power. So he's just going to come on down. And there's as simplified as you can make this algebraic expression. 3 terms. Done. Okay. All right. Ooh, what about this one? Whoa. Now, before you do anything, I know you see this 12, which is a constant, and you see this 15, which is another constant. It's really a negative 15. But this 12 is trapped right now by these parentheses. And the only way to get at this is to use the distributive property so that we bust out of these parentheses. So 7 times 1m is 7m. 7 times that plus 12 is plus 84. Now, no more parentheses. Bring down this minus 15. 7m has no other terms to combine with it, so it's just going to stand there. I have a plus 84 and a minus 15. Go ahead and combine those two. I get a plus 69. Done. These two cannot combine because they're not like terms. Wow. All right. Are you ready? Are you ready? Actually, I'm not going to have you do the workbook page yet, okay? What I want you to do is I have a worksheet for you, and that will be your assignment for today, all right? Watch these guys. So actually, go ahead and get your worksheet, and let's take a look at a couple of these. For example, number 2 here, okay? You have a 12R, but there's no other R's downstream. So now you have to combine this -8 and a -12. Remember, everything's really adding. Just stick that negative sign with the number there. You should get a -20 or -20. I'm just going to leave it like that, okay? Let's look at number 3 because things are all over the place. N. It's really one N. -10. Nope, not alike. +9N. Oh, yeah. 1N and 9N, those guys can combine. Okay? And then this -10 and a -3, they're constants. They're going to combine together. 10N. Watch your signs and stick them together. You know, there was a country song by Sugarland and the amazing Jennifer Nettles that said, "You and me, baby, we're stuck like glue." That's what I want you to think of with that negative sign. Stuck like glue to the 10 and stuck like glue to the 3. These two combined are like a -13. Boom, done. Can't go any further. Whew. All right, you've got a bunch of them left on this worksheet. I want you to go ahead, continue on, and as always, may the force be with you.